Hello, everyone. On behalf of the Environmental Finance Center Network, welcome to the sixth session in our Operator Certification series on Areas and Volumes Math. My name is Kristen Crew from the Syracuse University Environmental Finance Center. Before we begin, we're going over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. For questions you may have, please take note of the slide number at the bottom right of the screen. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance and personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or need assistance, please contact smallsystems@syr.edu. Next. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories throughout our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. And on that note, we can get started. I would like to introduce our presenter for the day, Rose Afandi. She's a program specialist with the Southwest Environmental Finance Center. All right, Rose, I'll let you take over.
So hello, everybody, and thank you for attending today's session. Today, our main session is we're going to be talking about areas and volumes. And to begin that, we will also understand a little bit about perimeters. And before we begin, I would request you to gather a calculator, some scrap paper, and a pen or a pencil, because we will be doing or working through some problems together. And because this is a math session and it's better understood, or it's better dealt with when you do some practice. So if you get a chance, please gather some scrap paper and a pen and pencil, and we will begin shortly. So areas and volumes, those are the basics, two of the basic topics in water certification math. And you will see these problems as you take your licensing exams. And so today we want to go back to the basics and make sure we understand how to deal with problems that are relating to areas and volumes. And that way we will be in a better position to answer them. So up front, I'd like us to talk about, as we deal with math problems, it involves a lot of calculations, and I want to introduce the topic of units compatibility when you're dealing with math problems, because as you read through every question you get, you may be given different units during using the same question. And so our main purpose is to make sure that we use the same units when we are calculating these math problems. And so conversions must be made before calculations are done. And therefore, to be able to do this, most examinees or the examiners will give you a formula sheet similar to this one here on the screen. Therefore, you do not need to memorize all these formulas or all these conversion factors, but it makes it helps to familiarize yourself with the formula sheet that will be given to you during testing, and make sure you know where to find the important formulas you'll be using in your math calculations. A good example is when dealing with math problems, you know there's an important formula, which is the conversion of cubic feet of water into gallons. And so when you're looking at your formulas, make sure you know where to find those conversion those conversion factors. Therefore, when you're doing math problems, you do not spend so much time looking for it on maybe a 5 or 7 page sheet of formulas. So up front, I want us to understand one terminology in drinking water math, which is perimeters and circumferences, and that will help us understand better the areas and volumes that we will be focusing on today. So perimeters are the distance around two-dimensional objects or surfaces. So we're talking about the perimeter around, or the distance around rectangles, squares, triangles. And then when we're dealing with circles, circumference is just another terminology of expressing the perimeter around a circular object. So let's talk a little bit about this, and to be able to explain this, we're going to walk through a problem together expressing the perimeter of this particular surface, which is a rectangle. And our question is, what is the perimeter of a rectangular enclosure measuring 85 feet in length and 60 feet in width? So a few pointers here when you're answering such questions, or any math question in particular, it helps to draw a sketch. If you have a scrap paper, draw a sketch, and then you will see something expressed visually in front of you. It's hard to miss something that's visually in front of you. Then if you have been given any units, it helps to add those units to your sketch. And then ask yourself, what is the question asking me for? And at this point, you look at what formulas do you need to be able to answer this question, and also ask yourself, what are the units? Are the units compatible, or do I need to make a conversion before I start? So I have drawn my rectangle here, and the question is asking for the perimeter around this rectangular enclosure. So I know that the perimeter is the distance around this particular enclosure. And when I put my units down, my formula I know is perimeter is equals to the length added to the width, added to the length, and added to the width again. So once I write down my formula, I will plug in the values that I have been given, which is 85 feet plus 60 feet plus 85 feet plus 60 feet. And when I add that up, I get my perimeter to be 290 feet. So at this part, I know that all my values are all compatible. I'm adding feet to feet. I'm not adding incompatible units, and therefore my question has been solved at that point. Now let's take a look at about a problem that expresses circumferences, and this is the circumference is the distance around a circular object. The circumference of what is the circumference of a circular clarifier that is 75 feet in diameter? Now, diameter is one of those terminologies you need to be familiar with, and this is the distance across the middle of a circle. Now, if you look at this, you can draw a sketch, and the circumference would basically be if you're walking around the edge of that circular clarifier. So the distance around that circular clarifier. We're not considering the volume at this point. We're only looking at the distance walking around that clarifier. So on my formula sheet, I know the circumference of a circle is pi multiplied by d, which is the diameter. And pi is a constant that you will be given in most math problems. It will probably be on your formula sheet, which is 3.14. And this is a truncation. It's a very long number, a never-ending number, but mostly you'll find it written as 3.14. So if you multiply 3.14 multiplied by 75 feet, and my answer is 235.5 feet. Now, with most math problems on your exams, you will find that there will be a rounding up or a rounding down. So be familiar with those rounding up and rounding downs, because the answer that will appear on your formula sheet, or sorry, on your exams might be rounded up or rounded down. And so you choose the answer that's closest to what you're looking for. Now we're going to go ahead and dive into areas, starting with areas, and we will later go on into volumes. And so an area is the measure of a region size on a surface or a two-dimensional space occupied by an object. And we want to make sure we understand how to calculate areas of different objects. And there are various applications where we need to learn about area. You might wish to know how much space you need to install your new tank. I mean, if you live in an area where we have hills and little, nice hills where you can install your tank at the top of a hill to give you enough water pressure in your distribution, you might wish to know how much space you have at the top of that hill for installing your new water tank. You might wish to know how much paint you need to paint your tank, whether you're painting the interior or the exterior of your surface. Or you might also need to know the cross-sectional area of that particular object, because it's important in calculation of volumes, such as when you're dealing with pipes or with storage tanks. So area is important to know how to do. Now we have areas of basic objects, such as a circle, a triangle, square, or rectangle, and that's the area we need to be familiar how to calculate. But not all objects are in our basic shapes. Sometimes you can have a combination of these basic shapes, and but you can still calculate the area of those shapes if you know how to calculate the area of the basic shapes. So the most common shape we want to be familiar of how to calculate is the area of circles. And when we look at our formula sheets, we will always be given the area of a circle. And there are two formulas here where we have formula as pi r squared, or you also have the formula of 0.785 multiplied by the diameter squared. Regardless of which one you choose, you will still end up with the correct answer. You just have to choose the one that you're most comfortable with. The diameter, as I mentioned earlier, is the distance across the middle of a circle, and the radius is half of that diameter. So those are concepts that you need to understand, the difference between the diameter and the radius. Now, some quick tips: pipe sizes. If you're dealing with pipe sizes, water pipe sizes, those are measured in terms of their diameters. So when they tell you we have a 6-inch pipe, it means the distance across the cross section of that particular pipe. Now, we're dealing with 3-dimensional objects here, so we don't want to confuse our areas with our volumes. When we're dealing with cross-sectional areas, we're looking at the area of that particular pipe, the cross-sectional area. Or if it's a storage tank, we're also dealing only with the top or the bottom of that particular object. So conveyance pipes, clarifiers, storage tanks, and other cylindrical objects will have a circular cross-sectional area that we might need to calculate the area of. So let's do some practice together and know how to do this. How much area do we need for installing 3 circular clarifiers measuring 16 feet in diameter? So as we go through these questions and as you go through answering them, make sure you underline the main points or the main words that you need to understand in a problem. That way you will know what you're being asked to do. We have our area. We're looking at cross-sectional area of those clarifiers. It's 16 feet in diameter. That means our radius is 8 feet. So I write it down and I'm looking at it so I do not confuse it. Now the formula that I prefer to use personally is pi r squared, and you can use this other formula if you wish. You will still get the same answer. But when you're using a particular formula, make sure you understand we are dealing with the radius here and not the diameter. So 3.14 multiplied by 8 feet, which is now my radius, multiplied by 8 feet again because it's pi r squared, meaning we have to multiply the radius by itself here. And my answer here is 200.96 square feet. Now it's important to track your units because it's very easy to make an error when you're dealing with units. Feet multiplied by feet, we come up with square feet. And at this point we are dealing with an area, so square feet is what we have. Now we haven't completed our question because we only have the area of one clarifier. If you leave your question or if you don't answer your question completely, believe me, you will find the answer on one of the answers to be 200.96 feet, which will be wrong. So you have to complete it because we have 3 clarifiers and we want to make sure that we multiply the area by 3 to get the full area of all the 3 clarifiers. So So 200.96 square feet multiplied by 3, and we get our area for the 3 clarifiers to be 603 square feet. So my tip here is make sure you read and understand the problem, answer the problem all the way to the end, and then make sure that your units are compatible. Okay, now this is the time for you to give it a try, and my question is, what is the cross-sectional area in square feet of a pipe that measures 10 inches in diameter? Now on my formula, we have both formulas. The area of a circle is pi r squared. The area of a circle is 0.785 multiplied by the diameter squared. So choose any of these formulas to use. We also have a conversion factor of 1 foot is equivalent to 12 inches. And so I'll let you guys give it a try, and then we will walk through it together. So go ahead and attempt that, and then we will pull up the poll, and you guys can answer that for me.
All right,
Okay.
I'll be launching the poll in 10 seconds. Everyone get your answers in. I will keep it open for another 20 seconds. All right, Rose, it looks like 39% of people chose 0.55 square feet. 35% of people chose 78.5 square feet.
Okay.
And then 20% of people chose 2.09 square feet.
Okay, thank you. So the correct answer here is 0.55 square feet, and we had about 35% getting it correct. So we had a big percentage that did not get it right. So we want to make sure we know how to do this. So let's go ahead and walk through this together. And the question is, what is the cross-sectional area in square feet of a pipe that measures 10 inches in diameter? So I have drawn a sketch here, and I've put in my units as 10 inches, my diameter. Now, looking at it, I already know that that is the diameter. So I want to write it down. What I'm going to use is the radius. So half of 10 inches is 5 inches. And then one thing is my units are not compatible. I've been asked to get this area in, of a pipe in square feet. However, my pipe measures 10 inches or in diameter and 5 inches in radius. So I have to do a conversion before anything can be done, and that is converting the 5 inches into feet. To do that, I have to divide 5 inches divided by 12, and that way my inches cancel. And what I'm left with is my radius is equivalent to 0.42 feet. So now I have my units compatible, and I can go ahead and calculate my area. Area of a circle is pi r squared. And when I plug in my units, 3.14 multiplied by 0.42 multiplied by 0.42, and my cross-sectional area of that pipe comes to 0.55 square feet. So for those who did not get this right, notice where you might have made a mistake. Maybe you forgot to do the conversion, or maybe you used the diameter instead of the radius and used the formula that was requiring one or the other. But it's important to understand how this is done. So next, we're going to look at the area of rectangles and square, and there are various applications where you might come across this. It's important to know how to calculate this. These are common shapes, and in our utilities, you might have maybe a clarifier or a membrane that's rectangular shaped. When we're dealing with these surfaces or with these volumes, we don't want to confuse areas and volumes. So the area is just the cross-sectional part of it. We don't want to confuse it with volume because it might, make us get the wrong answer on those problems. Now, the area of a rectangle or a square is simply the length multiplied by the width. Squares have all the four sides equal to the other. The rectangles have two sides that are equal to each other. And so make sure you understand those concepts. You might have aeration basins, or sometimes you might need to do some dirt excavations. You're digging out in the distribution. You want to know how much volume of soil you're digging out or what area you want to deal with. So all these are applications where you need to know the area of rectangles and squares. So let's do a practice problem together on the areas of rectangles and square. What is the area of a rectangular aeration basin measuring 100 feet in length by 100 feet in width? So when I draw my sketch, I'm able to put in the units that I'm given. That way I don't confuse anything. My rectangular basin is right here. I have my length as 100 feet and my width as 80 feet. My formula is also written out as the length multiplied by the width. And at this point, all I need to do is plug in the units. So my basin, the area of my basin will be 100 feet multiplied by 80 feet. And I will end up with the area of my basin as 8,000 square feet. So feet multiplied by feet is square feet. And then I'll go back to my equation and ask myself, did I answer it completely? They were asking me to get the area of a rectangular basin. And I think I have answered my question completely. So now we need to understand how to calculate the area of triangles. This is another basic shape that we see out in our utilities, in our distribution systems. And triangles are also, you will be given this formula on your formula sheet. The area of a triangle is a half multiplied by the base multiplied by the height. And the area of a triangle or a square is length multiplied by the width. Now for area shape number A here on our screen, we have the dimensions given. So by getting the area of a triangle is simply taking our formula and plugging in the values that we have been given. So a half multiplied by the base multiplied by the height. And that would be a half multiplied by 12, which is our base right here, and 10, which is our height of that triangle. And I'm coming up with an area of 60 square feet. My units are compatible with each other. I'm multiplying oranges to oranges, and feet multiplied by feet, the answer should be in square feet. Now my shape B is kind of a combination of shapes, and so to be able to get the area of that enclosure, I'd have to break it down into the basic shapes so that I can get the area of each shape and then add it up together. So there are two shapes here, and on shape B we have a square shape and we also have a triangular shape. So the area of that square is length multiplied by width, which is 12 multiplied by 12. And then I'll have to add that to the area of the rectangular shape, which is area of this part here, 10 by 10 multiplied by half. That is the area of the rectangle. And then you will have to add both of those areas together to get the complete area of that section. So I come up with 144 square feet as the area of my square and 50 square feet as the area of my rectangle. Those added together, I'm coming up with 194 square feet for the entire enclosure. Now, again, as I mentioned, this might be rounded up to 190 square feet, or a value that's close to that. So make sure you understand these concepts as you know how to calculate the area of all these shapes that we see out there. Now, the surface area is another concept we need to understand. Surface area is pretty much the surface area of any of these objects. And we're dealing with cylindrical objects. We'll have the top side of that cylinder, the sides, and also the bottom of that cylinder. And we might be asked to get the surface area of the entire cylinder, or maybe excluding the top or the bottom. When you're dealing with rectangular or square objects, you might also be asked to get the surface area. And we have rectangular objects and square objects, which are cubes. They have 6 sides to them. So make sure we want to make sure we understand how to do this. For cubes, all the sides are equal to the other, but for rectangular objects, 4 sides are equal to the other and 2 sides are equal to the other. So let's practice together, and we're looking at the surface area here. What is the surface area of a cylindrical tank? And we're looking at the top, the bottom, and the walls with a diameter of 125 feet and a height of 48.5 feet. Now, most formula sheets will give you a formula here, which is the surface area of a cylinder is 2 pi RH added to 2 pi r squared. But some formula sheets might be lacking this. So we will have 2 examples of how to work out this problem and make sure we know how to do it. So I draw out my cylindrical tank and I put in all the values I've been given. I know my diameter is 125 feet and the height of my tank is 48.5 feet. And I just saw a typo here, so we'll work through that. So the diameter 125 feet and the radius is 62.5, which is a half of this diameter here. Now, when you have this formula, basically the first part of this formula here, these are the sides of that particular cylinder, and the top and the bottom is this part here, the second part here. So when you have the formula, all you need to do is plug in the values that you have been given. Write the formula out and plug in the values. So as I plugged in all my values from what I have been given, and I make sure that I use parentheses to distinguish those two, meaning you have to use the PEMDAS rules of multiplication. You start with whatever is inside the parentheses first, and then you proceed on to the other parameters. Now I have my surface area here as 18,840 square feet, and I'm adding it to 24,531.25 square feet. And I'm coming up with my surface area as 43,371 square feet. So if you did the math correctly and you plug in your numbers, you should come up with a surface area of that particular cylinder of 43,371. That is the top, the sides, and the bottom of that cylinder. Now, if you're painting the tank and you're using this in different scenarios, for example, you're painting the tank, you might not need the bottom part of the tank. So you will need to remember to exclude the bottom part of the tank. And you can do this by just eliminating these two from your formula, and you'll still get a very accurate surface area of that tank, excluding the bottom part. Now, however, you might not have the formula, and at this point you might be panicking. I need to get the surface area of this cylinder and I don't have a formula. How do I go about it? On your formula sheet, you might only have the area of a rectangle or the area of a circle and the circumference of a circle. And this is where circumference comes in. When we started off with this series, we were talking about the circumferences of circles. Now, what I'd like to introduce is picture this cylinder as, cut on the sides. So open it up, cut it up, and what you end up with is, the 3 basic shapes, which is a rectangle and 2 circles. And if you plug in the values, you'll notice that the circle has the value of 125 feet as the diameter, and the width here is 48 feet as our width of that rectangle. So you're picturing this as a cylinder that's been cut open. That way we can get the area of this circle, the area of this, and add it to the area of this rectangle. So first of all, we want to get the area of the top and the bottom of the circles. And so we want 2 is signifying the top and the bottom. And the area of that circle is simply 3.14 multiplied by 62.5, which is the radius, and 62.5, which is the radius of that circle. Now I come up with the area of the top and the bottom as 24,531 square feet. So that's just half of the problem done. And we want to go ahead and also get the area of our rectangle, and then we can add those 2 parameters together. From what we discussed earlier, the circumference of the circle is equivalent to pi multiplied by the diameter. Now, my pi is a constant, 3.14, but my diameter of that circle is 125 feet. That is the circumference, sorry, the diameter of that circle. Now, if you get that 393 is the length, this is also equivalent to the length of that rectangle. So 393 feet, which is the circumference of the circle, if you open this up, it's also equivalent to the length of that rectangle. So at this point, we are now dealing with a rectangle, and the area of that rectangle is length multiplied by width, which is 393 multiplied by 48, and I come up with 18,864. Now I'm not done yet. I have to add all the areas together of the circles and that rectangle. And so adding all those together, I come up with an area of 43,395 square feet. Now, this is very close to the first area that we found, and it can be rounded up to the nearest whole number. So you might get an answer of 43,000 or 43,300 square feet. So whether you have the formula or not, know how to deal with such problems, use what you have and understand how to do it instead of memorizing, because you will not be able to memorize all this. So I want you guys to give it a try, and I want you to find the surface area of a cube if the sides measure 20 feet. So a cube has all the 3 sides equal to the other, and I want you guys to get for me the surface area, and the sides are measuring 20 feet.
All right, I'm going to launch the poll so people can get their answers in. All right, get those answers in. I'm going to close the poll in 3, 2, 1. All right, Rose, and it looks like most people chose 2,400 square feet, and about 20% of people chose 800 square feet.
Okay, good. Thank you for responding. So the correct answer here is 2,400 square feet. And so most of you got it correct, and that's a great job. Let's see where, for those who did not get it correct, they might have gone wrong, and let's work it together so we know how to do this. Now, when you're given such an equation and you've been given information within the question, they give you the information that this is a cube. When you see that, you know that all the sides will be equal to the other. So 20 feet, whether it's the length, the width, or the height. And if you draw your graphic or your schematic, you can put in the values there and you will know what you're dealing with. The question is asking us to get the surface area. And so we want to write down our formula. And we know that the surface area of one of these sides, one of these sides is just the length multiplied by the width. Now we have to know that we have 6 different sides when we are dealing with this cube, and all these sides are equivalent to the others, so we don't need to worry about other sides being greater than the other. They're all the same. So my surface area here would be of all sides is 20 feet multiplied by 20 feet, and then I'll have to multiply by 6 because we have 6 sides to this cube, and my answer is 2,400 square feet. So this is all sides, top, bottom, and all the 4 sides on the sides, all of them equal to 2,400 square feet. Now, if you are dealing with real life situations, for example, you're painting a box and you're not able to paint the bottom of the box, again, remember to either eliminate one of the sides, or if you're only painting a box that's open at the top, you know that you'll have to exclude the top part of it. And so real life scenarios come into effect, but if you're getting it as a full, if it's not specified in a math equation, then you'll just go ahead and calculate all the sides together. Now let's talk a little bit about rectangles, because rectangular shapes, they all have 4 sides are equivalent or equal to the other, and 2 sides are equal to the other. So not all the sides are equal, like we did in the previous problem. So for the surface area of a rectangle, we want to make sure that we only take 4 sides which are equal to the other, and then add them to the 2 sides that are equal to the other. The area is still length multiplied by width, but if you write it out, then you will not skip any of these steps. So write it out and put in the values that you have been given. This particular rectangle is 50 feet in length and 10 feet wide, and then it has a depth of or a height of 10 feet. So if you plug in your numbers, you'll know that the 4 sides are all equal to 2,000 square feet, and the 2 smaller sides are equal to 200 square feet. So here we get the area to be added all together to be 2,200 square feet. So make sure you understand the question and you don't confuse this, because one of the answers was the multiple choice answer will probably be the wrong answer of what you weren't really paying attention to. Again, scenarios such as painting, you have to be familiar with those. So we're going to jump into our next topic, which is volumes. And volumes are really important when you are talking about water math, because water is a solvent that kind of takes on the shape of whatever container it's in. If it's a cylinder, water will take on the shape of that particular vessel. If it's a square or a cube or a rectangular shape, it will take on that particular shape. Now we do have, items or vessels like clarifiers, or we have, excavations that we need to be familiar how to do, or maybe even conveyance pipes that contain water, and we want to know how to get volumes of such applications. Let's start off with volumes of cylinders. This is a very common vessel, or a very common vessel that we see in water math. And the volume of a cylinder will always be given to you on your formula sheet, which is pi r squared multiplied by the height. Now, a concept that helps me is to picture a cylinder as a stack of circles. So if you look at it, like you have one circle, and then if you take several circles and stack them on top of each other, you will end up with a cylinder. So the first part of the cylindrical equation is pi r squared, which is simply the area of a circle. And then the h part is, you can look at it as the number of circles on that particular stack of circles. It kind of can help you visualize what we are talking about with volumes. So our question here to make us understand better is, let's see, find the volume in cubic feet and in gallons of a tank measuring 20 feet in diameter and 50 feet in height. So this is a cylindrical tank. We want to know how to get the volume of this. The volume of my cylinder is pi r squared multiplied by the height. You write down the formula, and then you plug in the values that you've been given. I've been given my pi is a constant 3.14. My radius is 10 feet. We were given the diameter as 20 feet. The radius is half of the diameter. We have to multiply it by itself, which is the R squared, and then the height of the tank is 50 feet. Once you write it down, you will tell whether your units are compatible. It's feet, feet, feet. And I'm happy because I'm multiplying oranges to oranges and not oranges to apples. So when I go ahead and multiply this out, I get the volume of my cylinder as 15,700 cubic feet. So this is where now we are getting into volumes, because feet times feet times feet, we now get cubic feet. And that is now a volume that we are dealing with. However, when we go back to our question, we were asked to get the volume in cubic feet and in gallons. So we haven't completed this equation. We have only done part of it. So the next step here is we do need to convert this cubic feet into gallons, and that's a conversion you have to be very familiar with. You will get questions. You can be sure of getting questions like this on your exam. The conversion factor we are going to use is where we have 1 cubic foot of water is equivalent to 7.48 gallons. And so when you do that, you want to know that you will always have more gallons than cubic feet. So we want to take 15,700 cubic feet. We're multiplying by 7.48 gallons. And my units for cubic feet will cancel, and what's left on the table is gallons, and we'll multiply that out is 117,436 gallons. So at that point, we have answered our equation completely, and we did finish both in cubic feet and in gallons. So I want you guys to give this a try. I want you to find me the volume of a cylindrical clarifier. And this one, I want you to find it in gallons. The tank has a height of 10 feet. And it also has a diameter of 20 feet. So go ahead and give this a try and get me the volume of this cylindrical clarifier. And then we will work through it together.
All right, I'm going to go ahead and launch the poll so people can get their answers in. Get those answers in. I'll be closing the poll in 3, 2, 1. All right, Rose, so it looks like 80% of people chose 23,500 gallons.
Okay, good. Did we have any other answers out there? Anybody chose?
13%, 3,140 gallons, and then 7% chose 10,500 gallons.
Oh, okay, good. Thank you guys for answering. So a majority of us chose the correct answer, which is 23,500 gallons. And yes, so let's work through it together for the benefit of those who might not have gotten this, so we all know how to solve for this. Volumes of cylinders, let's see, the volume of a cylinder is pi r squared multiplied by the height. And when you draw out your cylinder, put in the values that you have at hand. Our diameter is 20 feet, and therefore our radius is 10 feet. And then our height has also been given as 10 feet. So if you write it out, you will know where the values come to or show up on that particular vessel. When you write out your formula, write it out in full, and that way you'll know which values go where. Our values are 3.14 multiplied by 10, multiplied by 10, also multiplied by 10. So feet multiplied by feet, multiplied by feet, we now will get a volume associated with it because it will be cubic feet. And our cubic feet there is 3,140 cubic feet. Now, some of you answered this, and of course, it was one of the values that you given, the choices you were given, because it's still correct. It is a volume, only that the question was asking for it in gallons. So we have to go one extra step to convert these cubic feet into gallons. And we see this a lot. It's just one other pointer that please read the question carefully and make sure you answer it correctly. So to convert 3,140 cubic feet into gallons, we want to set up our problem, and this helps me a lot when I set it up this way. I put my conversion factor as 1 cubic foot is equivalent to 7.48 gallons. Therefore, I want to know how many gallons are equivalent to 3,140 feet. So cross multiplication, that will come to 7.48 gallons multiplied by 3,140 cubic feet and divided by 1 cubic feet. Cubic feet and cubic feet will cancel with each other, and the value that's remaining is gallons. So my answer will now be in gallons, 23,487.2, which can be rounded down to up to 23,500 gallons. So your answer might be a value that's close to that, either it's rounded up or rounded down. So know how to do this and know where you got the answer wrong. That way you don't get caught off guard if you're dealing with these volumes. Conversions will appear on your math exam. So let's talk a little bit about volumes of pipes. Pipes is, those are areas that we know we have pipes in our distribution systems, whether you're dealing with drinking water or whether you're dealing with sewer pipes. And to be able to do this, let's work through a problem together and make sure we understand. So your main 2-feet sewer line collection system runs for 5 miles to the wastewater treatment plant. How many gallons of wastewater are in the pipe during peak usage periods? So we know from our formula sheets that the volume of a cylinder is pi r squared times height. We also know that our conversion factor is, 1 mile is equivalent to 5,280 feet. Write it out, hand, so you know what you're dealing with. You can also draw a schematic, so you know this pipe runs for 5 miles, and 5 miles will also be equivalent to 26,400 feet. We have our pipe diameter as 2 feet, therefore our radius is 1 foot. And the first thing we want to do is we want to get the volume of water in that pipe. And we're dealing with the entire pipe at this point. So pi r squared times height, we get the volume of that pipe. If you plug in your values correctly, the volume in the pipe is 82,896 cubic feet of water is in the pipe. And that is the full pipe. So we haven't divided it at all. Now, one other knowledge we know about gravity flow wastewater mains, those are designed for half full capacity. This is information you as a water operator needs to be familiar with. When they give you that question, when they tell you peak usage period, they know that half of the pipe is what is required. So the volume of that pipe, we will take half of that, and the volume we're looking at is 41,448 cubic feet. Now we want to be able to convert that volume into gallons so as to know how much water is in there. And the conversion factor, of course, we will be multiplying it by 7.48 gallons multiplied by 41,448 cubic feet. Feet and feet cancel with each other, and we have our volume as 310,031 gallons in that pipe. So during peak flows, we expect 310,031 gallons to be flowing through that water main pipe. Okay, and of course that can be equated or 310,000, it can be rounded up or rounded down as needed. Now, the last part of volumes that we're going to look at is the volumes of excavations, and we're dealing with collection systems of buried septic tanks. You might be required to do a problem that has something to do with excavations. So let's deal with that and learn how to do that. You need to dig a 4-foot deep by 3-foot wide trench for a collection piping system. The pipe will run for 2 miles to the lagoon system. How much fill dirt in cubic yards should you order to replace the native excavated dirt? So as you dig out this soil, sometimes you might be required to order new soil to replace the native soil, because different pipes have different requirements. You might have the native soil not a very good fill dirt, and you might be required to get additional fill dirt to replace that native soil. So this is that problem that you need to know how much of that dirt to order. When we're dealing with excavations, think of it as kind of like a rectangular box that runs for 2 miles. So a thin rectangular box that runs for 2 miles. And when you draw the schematic, 2 miles is equivalent to 10,560 feet, because 1 mile is 5280 feet. It's on your formula sheet. This particular trench is 3 feet wide and it's 4 feet deep. So draw it as a rectangular box and you will come up with the volume of that as the length multiplied by the width multiplied by the depth. At this point, if your units are compatible, you've converted your miles into feet, you will put your units down in feet, which is 10,560 feet, multiplied by 3 feet, multiplied by 4 feet. My volume comes to 126,720 cubic feet. Now we are dealing with a volume. Now we have our our volume in cubic feet. You might stop here, and actually one of the choices might be this one here, but you will find that this is not correct because you have not completely answered the equation. So we have to go one extra step and convert these cubic feet into cubic yards. And from our formula sheets or from our general knowledge, we know that 1 cubic yard is equivalent to 27 cubic feet. So as you set up your problems, make sure you set them up correctly so that you know what is cross multiplying with the other. And that way we know that 126,720 cubic feet multiplied by 1 cubic yard divided by 27 cubic feet. So cubic feet and cubic feet cancel, and our answer is 4,693 cubic yards, because cubic yards is the units that did not cancel here. So if you keep a track of your units, you will know whether you've done the math correctly and what canceled and what remained with the other. This can be rounded up to 4,700 cubic yards. And this is important because you will know how much dirt to order when you are trying to replace your native soil. So at this point, if there has been any questions that have come along the way, you could please let us know whether you have any questions, and we can work through them together, or we can get back to you on this. But James, are there any questions that came up through the chats?
So far, nothing has come through. We've got a few minutes left, so there is still some time to throw in a question if you have one, but so far, nothing.
Okay, good. So if there are any questions, whether you think of them now or you think of them later, or you want to work through some problems regarding area and volumes, please reach out to any of us. We are, here is our contact information. James and AJ are here also if you need to reach out to any of us. And we can work through these problems with you. Make sure you know how to understand these basics. With water math, a lot of people have anxiety related to math, but think of it as just playing around with numbers. And once you know how to solve a problem, then you'll be comfortable solving these problems, and you don't need any memorizations like you would do with other problems on your licensing exams. So it's just math is fun. It's fun to understand how to do it on your exam, as well as how to use these concepts in your day-to-day running of your systems. How do you get, if you want to order some paint, how much paint am I going to order? How much filters do I need to order? How much water is in that tank? And then calculating or using those volumes to calculate things like pressure, or to calculate things like all those applications that you might see in your drinking water systems or wastewater systems. So I see that we have some time. We're going to remain on. If there are any questions that you have, please put them in the chat, and then we will get back to you on this. But we will continue on with this series. We will be dealing with more complicated math functions as we go on. So make sure you join us next time, and we will be talking about more math concepts that you need to be familiar with in your licensing exams.
We do have a couple of comments that have come in. First is a question about whether this webinar is being recorded. Yes, it is. You will get links to the recording shortly. And one of our attendees said, thank you to Rose for going at such a moderate pace so that everybody could follow along.
Yes, thank you guys. And we will also send out, I think we already have the slides in the chat for you to download, or they will be emailed to you, so you can have these as reference and then know how to work through this. And if you have any questions, you can always reach out for some assistance. We do have assistance for you guys. We can work through these problems together.
And here's actually a question I think Kristen can answer. At one location, they've got a couple of extra operators who've been watching the series with them. Question is, how do they get credit? I believe you have to be signed in with a unique ID to get a certificate that has your name on it. Is that correct, Kristen?
That is correct. But if you want to email smallsystems@syr.edu and just give us the name of those individuals, we can get them credit as well and send them over certificates when we send those out.
Excellent. There's always a way, you just have to ask.
Exactly.
And we're
We'll
getting
allow
several
everyone another minute or two
you.
to get any other questions in.
Small systems at what is it, syu.edu?
I'm just going to message it to her so she has it.
Yeah, actually, you might want to just throw that out to everyone, just in case.
Yes, and if you don't get it, you can also just email it to southwestefc@unm.edu, the one that's showing up on the screen, and we can forward it to Syracuse. Okay, so if you have no other questions, I appreciate you guys joining us today, and we have these sessions running at least every week, and be sure to look out for this in your mailboxes and be able to join us. And we appreciate your time, and we hope you can join us next time.
And a huge thank you to you, Rose, for sharing your expertise with us today. Following this webinar, everyone will receive a follow-up email with the slides and the link to the recording. We also ask that you complete the webinar evaluation following the webinar so you can let us know your thoughts on today's session, as this helps us plan for future webinars on topics that are important to you. Thanks again. We hope to see you all at future EFCN events.